Welcome back to Mr. DuPage's class. This next lesson is for my Algebra 2 class for Monday, August 8th. This is about pattern recognition using buttons that will lead us to the linear growth models that we'll need to use for the rest of the year. Let's get into the lesson.
As I said before, this is for the date August 8th. 8/8 needs to go on our date line. This is about using buttons to figure out pattern recognition that will lead to our linear growth understanding. The first part we're going to look at here is just a story problem. Gita plays with her grandmother's collection of black and white buttons. She arranges them in patterns. Her first three patterns are shown below. As you see, in each one of the first three patterns, there is one black button. I'm going to use a blue button to represent our black button. Our job now, after looking at those three patterns, is to draw the fourth. Let's look at the white buttons in each pattern. In the first pattern, there are 1, 2, 3. In the second pattern, there's 1, 2, 3, 4, 5, 6. In the third pattern, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. As you can see, it goes up by 3 depending on each pattern. So what do we need to do in pattern 4? Well, I need to draw 1, 2, 3, 4 buttons in each leg. I will draw 4 buttons for each leg. This now we can tell it's going to add 3 per pattern, one level of the pattern increase. So how many white buttons does Gita need for patterns 5 and 6? Well, in pattern 4 I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I have 12 in pattern 4, then pattern 5 will have 15 and pattern 6 will have 18. Explain how we figured that out. The white buttons, as we said a couple times now, the white buttons increase by 3 every new pattern. The number of white buttons is equal to the pattern number times 3. So the number of white buttons is equal to the pattern number times 3. All right, on to number 4. Gita thinks she needs 70 total buttons. This is total buttons in all to make pattern 24. How do you know that she is not correct? Well, looking back at the explanation in number 3, the number of white buttons is equal to the pattern number times 3. So just for white buttons, if our pattern number is 24, we would take 3 times 24, which equals 72. We know we need at least 72 buttons. However, if we go back up and look at our pattern, look at just pattern number 1 will do, there are 3 white buttons, but there's also the 1 black button that has gone through each one of our patterns. If there's 1 black button, then it would be 72 white buttons. 72 white buttons plus 1 black button. Well, if there's 72 white buttons plus 1 black button, the answer to question number 5, how many total buttons does she need for the pattern? She would need 73. Let's look at our next story problem. In each of the problems below, the first 3 patterns of buttons are shown. For each problem, predict the number of buttons for patterns 4, 5, and 10, and then write a general equation to show the total number of buttons. The general equation is going to be something similar to what we said above, where we said that it's the pattern number times 3, and I'll show you how to write that in 1 second. So in number 6, there are 1, 2, 3, 4 buttons in the first pattern. 1, 2, 3, 4, 5, 6, 7, 8 buttons in the second pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 buttons in the third pattern. So this is increasing by 4 every time. What's one way to think of that? Well, I can take the pattern number and multiply by 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. And as we know from what we counted a minute ago, that is how many white buttons there were. So if my pattern is 5, then I can just take 4 times 5, and that will give me 20 buttons. If my pattern is 10, that would be 40 buttons. If my pattern is 33, that would be 132 buttons. Now on to the general rule. The general rule is the number of buttons is equal to what? Well, we said in order to figure out how many buttons were in each pattern without counting them individually, we just took the pattern number and multiplied by 4. If I did not give you a pattern number, or say I gave you a pattern number of 100, you could take 4 times 100 and give me an answer right away without having to actually draw the picture or count the number of buttons. So your general rule is going to be 4n, where n will represent the pattern number. N would represent the pattern number. So if I wanted to continue there, 4 times, or what is the number of white buttons if our pattern is 50? We would just take 4 times 50 to find out the number of buttons. Let's look at number 7. Number 7 is going to be a little bit different. Let's just count the number of buttons to start with. We have 1, 2, 3, 4 in the first pattern. We have 1, 2, 3, 4, 5, 6, 7 in the second pattern. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the third pattern. What are we increasing by every time? Well, we're increasing by 3. So we know it's going to be an increase of 3 every time. It's an increase of 3 every time. However, 1 times 3, or 3 times 1, is not going to give me 4. Well, why did that happen? Let's look at the legs of each one of our patterns. So there's how many legs in each pattern? Well, there's 3 legs to each pattern. It increases by 1 button on each leg. That's why we end up with an increase of 3. However, the center button in each pattern has stayed. I have not added anything to the center of these patterns. So really what my rule would be, it would be 3 times 1 plus 1. 3 times 1 plus 1 is 4. 3 times 2 plus 1 is 7. 3 times 3 plus 1 is 10. So now we figured out our general rule. We can put our general rule down here already. It would be 3n, n being the pattern number, plus 1 because we started with 1. If we went back to n equals 0, the only button that would still be there, because going back the other way we would subtract 3 buttons, would be our center button. So now let's answer, when the pattern is 4, how many buttons am I going to have? Well, it would be 3 times 4 plus 1, which would be 13 buttons. When n is 6, it would be 3 times 6, which is 18, plus 1 would be 19. When n is 10, it would be 3 times 10 is 30, plus 1 is 31. All right, let's move on to the back. What we're getting here is we're starting to understand patterns, which will lead us to being able to use a linear graph and understand linear growth. Let's look at the next problem we have here. In pattern 1, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Pattern 2, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Pattern 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I had 9, I had 12, and I had 15. How many buttons are we going to have in pattern 4? Well, it's increasing by 3 every time, so I will have 18 buttons in pattern 4. As you can see from pattern 1, to pattern 2, all I've done is added one more button per leg, which again, there's 3 legs. I've added one more button per leg to make my next pattern. So for pattern 4, there's 1, 2, 3, 4, 5 in each leg. So I need 6 in each leg. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Now that is our sequence. Our change is going to be a little bit different here though. Let's look at what pattern 0 would look like. As I increase, we add 3. So if I decrease, go back the other way, then we would have to subtract 3. So I'm going to take one button away from each leg. We'd have 1, 2, 3, 4, 5, 6 buttons. Still have our Z, still have the same pattern. There's only 6 buttons in pattern 0. So let's describe the change in the pattern you see above. The initial change that we saw is one button is added to each leg for a total of 3 buttons. Can we think of a rule for this though? If we have pattern 0 would be our N, correct? Well, knowing that we're adding 3 buttons per pattern, we know, based off of what we were doing before, that our rule would start with 3N. Well, if N was 0, in this case so far, our pattern number is 0, then we should have 0 buttons. However, there were 6 at time 0, so we need to add 6 to each leg. Let's see if our rule works. Well, 3 times 1 would be 3, plus 6 would equal our 9. So our pattern rule does hold true, at least for the first pattern. You can check pattern 2, 3, and 4 if you like, but it should still hold true. Now, number 10 is still talking about these patterns up here. We need to fill in the table below with the total number of buttons per pattern. We want to graph the pattern number and the buttons as points on the graph. I'll explain how to do that in 1 second. Let's just look at the table to start with. Well, pattern 0, we just talked about 1 second ago. How many buttons would be in pattern 0? 6. Pattern 1, there would be 9. Pattern 2, there would be 12. Now here, you need to be careful. It did not go to pattern 3, so we can't just add 3 to that. It went to pattern 4, so I skipped 3. So 3 actually would have 15. We would add 3 to that. But then we need to add 3 more because we've gone to 4. So it's going to have 18, just like we said up here. There were 18 buttons in pattern 4. So every 2 pattern levels we go, we need to add 6 buttons. So 18 plus 6 would be 24. 24 plus 6 would be 30. And 30 plus 6 would be 36. This is where the linear growth part comes into play. Everyone remembers what a linear graph is, right? It's going to be a straight line. So what we're going to do here is we're going to plot our table, and hopefully we should come out with a straight line. So at 0, we're going to have 6 buttons. At 1, we're going to have 9 buttons. Just put it somewhere in between 8 and 10 there. At 2, we're going to have 12 buttons, which is right on that line. At 4, we're going to have 18 buttons. At 6, we're going to have 24 buttons. So I started at 6, went up to 24. I went up to 24. You don't need to draw that dashed line. I'm just showing you how I did it. At 8, we're going to have 30 buttons. So where's 30? 30's right there. And at 10, we're going to have 36 buttons. So I'm going to go up to 36, which is right here. Now, I'm going to get rid of those dashed lines for us so we don't get confused. Now, if I connect all those points, I should have a straight line. Just like when we did the linear graphs review last time, you want to make sure you have something straight to make your line with. And again, this is going to have an arrow straight out. The reason why I do not have an arrow back down in this area is, can I ever have a negative pattern? No, you cannot. These are going to start at 0. So it does look to me like we have a straight line. So this is now a linear graph based off of our table and our information. So we need to use slope-intercept form. Remember, slope-intercept form from last lesson is y equals mx plus b to write the equation to fit your graph. First thing we want to look for is our y-intercept. Where does it cross the y-axis? That would be at point 0. Well, that is at 6. So my b value, it would be plus 6. The next thing I want to look at is a perfect point that it crosses. In this case, I went up 2, 4, 6, and I went right 1, 2. So my m value is going to be 6 over 2, or 3. So it would be y equals 3x plus 6. Now remember, from just a minute ago up on line number 9, we said that our rule for this button pattern would be 3n plus 6. It holds true with our slope-intercept form, which matches our line, means everything has come together. So we need to use the equation to find the number of buttons in pattern 21. Remember that the x value will be your pattern number. Just like if I used n there instead of x. So all I have to do is take 3 times 21, add 6, and it'll come up with our answer. 3 times 21 would be 63. 63 plus 6 would equal 69. So in pattern 21, there would be 69 buttons. Let's look at the next problem. A certain pattern of buttons uses the equation y equals 5x plus 3 to express the number of buttons y for pattern x. Draw the first 4 pictures of this pattern. Well, the first picture I want to draw would be pattern 0. If I look at pattern 0, I'm going to put 0 in for my x value. I'm going to put 0 in for my x value. So this would be 5 times 0 plus 3 will tell me the number of buttons I need. Well, 5 times 0 is 0, plus 3 is just 3. So I would need 1, 2, 3 buttons. Okay? Now let's look at pattern 1. Again, I would take 5 times 1 plus 3. Well, 5 times 1 is 5, plus 3 is 8. Let's keep the same 3 buttons, because those are going to be in every picture, right? Now I just need to add 5 buttons. To do that, I'm just going to bring them over here and add them like that. Pattern 2, it would be 5 times 2 plus 3. Well, 5 times 2 is 10. 10 plus 3 is 13. Again, my 3 buttons that I started with originally. Pattern 1's picture. Well, how many buttons do I need to add now? I have 8 already. I need to add 5. So one more line of 5 buttons will give me pattern 2. Let's look at pattern 3, or our final pattern we need to look at. This would be 5 times 3 plus 3. 5 times 3 is 13, or 15, I'm sorry. 15 plus 3 is 18. So again, using the same pattern that I've used before, my first 3 buttons that'll be in every picture. Here is pattern number 2. I just finished pattern number 2. And here is pattern number 3. I have 5, 10, 15, 16, 17, 18. There are 18 buttons there. So what I'm going to do is I take my pattern number. Let's look at our y equals 5x plus 3. I'm going to take our pattern number and plug it in for x. I'll take 5 times that pattern number and I'll add 3. So for 0, we just talked about it. Still using these patterns. For 0, I have 3 buttons. For pattern 2, which is right here, I have 13 buttons. For pattern 4, we do not have pattern 4 there. But how can I solve for pattern 4 quickly? It would be 5 times 4, which is 20. 20 plus 3 would be 23 buttons. Pattern 6, I would take 5 times 6, which is 30. 30 plus 3 would be 33 buttons. Pattern 8, I would take 5 times 8, which is 40, plus 3, get 43 buttons. Pattern 10 would be 5 times 10, which is 50, add 3, and it would be 53 buttons. So again, if we start at 0, 0 is right here. I need to go up to 3. Well, 3 is not going to be super easy to find, but just make it just below the 5 there. The next pattern I'm going to look at is 2. Well, 2 has 13 buttons. Here's 2 on my graph. I'm going to go up to 13, which is somewhere in there. Pattern 4 has 23. 4 is right here, so I go up to 23, somewhere in that region. Pattern 6 is 33. Here's 6. Go up to 33, which is somewhere in that region. Pattern 8 is 43. Here's 8 right here. Need to go up to 43, somewhere in there. Pattern 10 is right here. We said we needed 53 buttons for that, so I'm going to go up to about 53 and put a button or a point there. What's the last thing I have to do to graph the line? Well, I need to connect all my points. So I'm going to start at the bottom, draw a line that goes through all my points. Hopefully you have a ruler, which means that you'll have a little bit straighter line than I do. And there is our line graph. If you wanted to just use your slope and intercept, which comes from right here, you would have the exact same line as what we just graphed.
That concludes our lesson for today. What we looked at is we saw some pattern recognition using buttons that led to a better understanding of how linear growth will work with patterns. If you have any questions after this video, please feel free to raise your hand. Your homework will be the buttons practice worksheet that you should have picked up on the way in the door. And have a great day.